This is a quick presentation and a demonstration for how to deliver a catalog of open source data to the GeoINT Services platform. First, we know that NGA and other parts of the intelligence community is increasingly leveraging unclassified sources as an integral aspect of their delivery of intelligent products. Yet searching for and accessing this content from public and commercial catalogs is difficult and very time-consuming. We know that there's nearly an unlimited supply of open source content, but yet accessing this content requires knowing where to look, which locations contain the content, and the use of custom user interfaces and APIs. As the number of these locations grow, locating the right information becomes very time-consuming and frustrating, as you have to learn more user interfaces and search more sites. At some point, people simply stop searching. This causes them to potentially recreate content that already exists, but which simply cannot be found. And this also leads to loss of opportunity and errors in decision making. Our goal, a solution, is to provide a single point of search across all content. We can do this by leveraging existing software that is already integrated within GeoINT services. We can do this by leveraging Voyager's existing framework for connecting to a wide variety of content connections or content repositories. Here you can see highlighted our Planet, Digital Globe, Airbus, Landsat. Voyager supports over a couple thousand different formats with APIs that can also connect to content such as stored in S3 file systems or custom APIs provided by some of these vendors. Where necessary, we can also develop new lightweight plugins for connecting to other systems by simply reading their APIs and pulling that content into the Voyager platform. Once indexed, we can integrate with the GeoINT viewer. We have a number of different web viewers of our own. And then we can also use that catalog and plug it into other solutions within GeoINT platform. And we have a number of APIs that provide developer access using open standards. So how does this work? First step is to develop a catalog in the unclassified environment. So on the right-hand side, we have any of the different open source content collections we want to index. We index those using Voyager and storing it there. And then we have a search experience that anyone can use within the open web. Next step is to take that catalog, only the catalog, and we can pull that up into the classified environment. So we're simply copying all the indexed records and their thumbnails and any other metadata properties. We do not move any of the data. Next, we can incorporate, in that same classified environment, we can incorporate a content index of classified content. So we use other Voyager instances to index other data that's sitting inside their classified network. We can merge these indexes for a single point of search across all the data. So we simply link these indexes or merge them into a single larger index that provides an experience where people can search for and find content, both the classified network and what was available on the open source network. Users can access the classified content through direct data delivery or by simply knowing where the data is. So people can query, we can provide response to whatever data they're looking for. And then they can take a particular item that they like to use, they can request it, and then we can provide direct delivery by giving them the path to where the data is at inside their classified environment or the URL where they might access it. We can also access open source content through a shopping list and by moving data from the open unclassified environment up to the classified environment. So similar to the first example, people can query for data that they might be interested in. We provide responses. They can look over those responses, and then they can request that content. But here, the fourth step is different. We provide them a list of the items that they're interested in from open source resources. And then we can, using that list, the person, or we can use existing systems to source that content from the open source system, take that shopping cart, collect the files, and then simply move that data up into the classified environment. So next thing we like to do is show a quick demonstration. In this demonstration, you'll see the Voyager out-of-the-box software that's running inside the GeoINT Services unclassified environment through the URL that you see here at the bottom of the screen. This index has been created by connecting Voyager to various different open source content collections. And through this experiment and prototype, we've simply connected to AWS Landsat data. These are 12 million records that have been stored inside of Amazon's S3 storage. We've also connected it to a collection of NAPE imagery to show another type of imagery catalog that's also available inside of Amazon's S3 storage. We've also worked with 3 of the different vendors that provide satellite imagery. We've worked with Planet, Airbus, and Digital Globe. In working with them, they've simply given us an evaluation key and also access their APIs. We wrote a simple connector that allows Voyager to connect to those catalogs. By passing the API key, we can query their system, and then we can pull down the records that they have. We also generate thumbnails, or we reuse thumbnails that they've already hosted. So this demonstration contains about 14 million records across these 5 different open source, free, and also commercial content collections. This is a quick demonstration using Voyager's out-of-the-box software to create a catalog of open source content that's both freely and also commercially available. This user interface is Navigo, Voyager's out-of-the-box user interface. It contains a familiar keyword search box along with a query for searching for content in a particular location. Down below we have their cards that can show various featured content, but most interesting we have the list of collections that we've indexed for this prototype. So here we have about 14 million total records. This has been broken up over Landsat data that has been stored in Amazon's S3 storage, as long as some NAPE imagery that's also stored inside of Amazon S3. If you're not familiar with it, NAPE is aerial photography captured by the U.S. Department of Agriculture. We also have Planet, Airbus, and Digital Globe content. For this content, we simply pointed to various vendors' APIs. We connected to their servers. We iterated over their catalog, pulling in a few sample records from each location. Again, there's no content that's been moved. This is just simply a catalog of that data. Now, once the catalog has been generated, we can simply explore it using a spatial or keyword search constraint. Here, I'll look for data in Brazil. So here we can see all the content stored in and around Brazil. We have about 650,000 items. If we'd like to see where the content is actually distributed, we have a heat map that shows the spatial footprint, or rather build a heat map on the spatial footprint of the data. I can narrow that down. I can see that there's quite a bit of content here around Rio de Janeiro. We'll search. We can see all the various items. There's 11,000 records. We have content from various satellite providers, Landsat, Airbus, and Digital Globe. We can use faceted search to query the catalog based on content that was searched across any of these different providers using a particular date range, the number of bands, pixel depth, the satellites, and any of the other properties that came back from those individual vendors. Here it looks like we have quite a bit of data that has cloud cover. To remove that, we can use that faceted search to reduce the items to only the ones that have suitable cloud cover. We'll say 20% or less. Now that reduced our catalog down to just 3,900 items. If we wanted to drill into one of these items to learn more about it, we can simply click on the card. This shows you properties about the data. This happens to be content that was captured by the Landsat sensors. So we see an overview map of its footprint. We see a thumbnail for the particular item. We see various properties. There's also relationships when you have a scene that might contain a number of different images or bands. You can access this data by its URL directly, or if you prefer, we provide a download option to download the file directly, right from, in this case, S3 storage. We also have a way that you can take this item and add it to a cart. So just like any type of modern shopping application, we can browse through the catalog, add various data sets to a cart, and then once I'm done, I can download all those items at once, or maybe open those items in an application to do something with it. Here I'll return to the search environment. Now let's look for some other data. Here we'll look for content around Ukraine. Here you'll find that we have the same constraint where we have cloud cover 0 to 18%. Here I'll remove that constraint to open up the catalog to more content. And once again, we can see our heat map, our coverage. And we can, again, browse through this catalog to see thumbnails from the various different vendors. Let's bounce over from the Ukraine. Let's look at some of the content that's stored in the USGS catalog. Let's look at some of the NAPE imagery. So here, let's look for content that is around Huntsville. Perhaps I'm working on a project we're looking for imagery that is over this Tennessee River in this area that connects the Wilson Lake down to the Guntersville Lake area. To do that, I can simply use a line search tool to follow content that follows this area. You'll see that I have options. I can look for content that intersects this line or within the line. So now I might want to narrow my choices so that I'm only working with NAPE imagery, not Landsat data. And then now that I have this Landsat content, I might want to, since I digitize a pretty rough line, I might want to use a search constraint to show any content that's within 5-mile buffer of this area. Now once I have these items, I can simply work with each one. I can add them all one to the cart at a time, or I can take all of the items and add them all to the cart to help facilitate download of this content.